Good morning, fans. Today we have LeetCode questions 1026, question number 1026, and in which the question is saying that the maximum difference between the node and ancestor. So it is saying that the given root of binary tree, this is the binary tree is given, and find the maximum value v. Let me little zoom it. Okay, so I have zoomed these questions, and you can see that it is saying that the given root binary tree and find the maximum value v, for which there exist different nodes a and b, and where v equal to a minus b, and both values, and a is the ancestor of b, right? Means a node a is an ancestor of B if and either any child of A is equal to B, or any child of A is ancestor of B. Let's see, this is A and this is B, right? Or A, you can say this one. Okay, so A will be what, 8, and B will be what, 6, like that only. So it is given, this is the binary tree is given, right? And output is 7. How? You can see that we have various ancestor difference, and some of which are given below, saying 8 minus 3, right? 8 minus 3, what we have? 5. 3 minus 7, what do we have? 4. This 3 and this 7, 4, and 8 minus 1 is what? 7. Like this, we have some differences. All among all possible differences, maximum value of 7 we have obtained from 8 minus 1, right? 8 and minus 1, right? And obtained by 8 minus 1 equal to 7, and that's why we are giving it on the 7. Okay, so that's why it is seeing the maximum difference between node and ancestor. This is node and this is ancestor. This is node and this is ancestor. Okay, and so that we have some approaches that we will see here, right? So the question is given already solution, right? The question is already given solution, right? And in which we have to we will start with what? We will start with the solution, and that solution should be what? Uh, from very beginning, right? And we will go with brute force algorithm, and we'll see how the we have to solve it, right? So first approach we have, and before that we'll see the overview, right? So we have already understood the overview, and it is saying that the problem is one of the three typical tree problems, right? And in which it can be implemented using the recursion, and we could simply perform recursive tree reversal, and also with a little insight we have, like we can implement slightly different approach. And below we will discuss two similar approaches, recursive and maximum minus minimum, right? Maximum minus minimum, two approaches we have, and then we will go through. Both are recursive approach, but later on are little insight, right? So we'll see that. And the first approach we have is recursive, right? So what I'll do here is I will write here recursive solution. Okay, so let me do what I can do here. I can increase this font, and yeah, I think that is good. So what we have to do first, let's understand the intuition. Okay, so we are going to start the recursive solution, right? And what does it mean, right? So let's start from the brute force. Brute force is saying that a typical brute force approach is to compare every node with its ancestor, right? And in ancestor means parents, you can say, right? And parents, okay, our oldies, right? And in the other words, we have to compare every node pair, and when a tree is a single line, right? And the time complexity would be O n square, because n is a number of nodes in the binary tree, and we can how we can simplify it is, since the problem asks us the maximum difference may be we do not need to compare all ancestor for a given node, and we only need to compare ancestor with the maximum and the value minimum, right? We don't want to do minus with all the ancestor, right? We will do with the maximum value and the minimum value, right? And therefore given node we only need to maximum value, right, and the minimum value from a root to this node. To achieve this, what we have to do, we can define a function helper, right, and the helper function to will start recursion which receives a node and two integers, right? The what we can do here, the maximum and minimum value of its ancestor we will take as input, and in this function what we'll do, we will need to update the maximum difference and the current maximum value, right, and current minimum value we will update. So algorithm should be very simple. We will initialize a variable result, and to record the maximum difference, what we should do, we will define a function, right, and which takes three arguments, right? Let's see, let first implement and then we will discuss, right? So as I told you, I'll take a variable that is called result, and we will initialize from what, 0, right? And we should create one helper function, right, before going to here, right? We'll take one helper function, and the helper function will give you, we will take a node current maximum value and current minimum value, right? So we'll take void helper, and we'll take tree node, and we'll say node, and int what, current max. Okay, current max comma, we'll take integer current mean. Okay, three things it will take as an input, and we will see first if node equal to null, right? Then this is the base case, we will return null, correct? This is called base case, and because we don't want to traverse, if the node is already null, then why will go to up, right? And then what we will do here, we will update result, right? Update, what we will do, update result. How we will update the result, right? So we will take we will take a variable we can make possible result. What can be the possible result we will have? We'll take math dot max, and we'll take two argument here, math dot absolute value we have to find, right, apps, and in which we will pass current max in comma current mean, correct? And whatever the value we have, we will take it, right? And sorry, max, in the max we will take similarly this line, and current, it should be mean, current mean minus, we will take the value of the node dot val, right, node value. And what will happen here, we will get the integer possible value, right, int possible value, and then we have to update with the result, right? Then we will have the result, and result will do mathematics, right? Max value will take whatever the max we have, the current max, right? Sorry, we have already the result, default value result 0 we have, and the next value that it came from what, possible, which one is maximum, we will store into the result, because we have to return the maximum difference, right? And next what we have to do, we have to update the max and mean, right? So now update max and mean. How we will do that? Current max, current mean, right? So current max is what we have. Current max what we have, we will have math.max, right? Math, if we have here, you can get it from here, right? Math, yes, it should be max. Current dot sorry, math dot max is current max dot node value. It should be node value. Current value, what should we have? The current max and max value. And then similarly we will do current mean, and we'll start with from here to here, and we will take minimum value, right? And to do that we have to call mean, not max. It should be mean, and current mean, we will take current mean, right? And the node, similarly the node dot val, correct? So we will have the current maximum and current mean. Now in this way we will update each time, and we will update our current and current max and current mean. But we are doing we have to do for the all the node, right? We have to do with for the all the node. That's why we will call internally the same method, helper, right? And helper will go, because we are passing starting is what we are passing node, right? Now we will pass a node dot left and right, right? We will start first left, comma, current max, comma, current mean. And similarly we have to copy this, and we will do for the right child. We'll do for just we will update right, and I don't think it is required to go up, and then we will return, and we are not going to do anything else, right? So method is void, we will break it here, and in this way we will update our result, right? And similarly we will update our what, current max and mean, and regularly we will do for all the nodes by using the traversing the with the left and right. So it is very easy, right? Now how we will call here, right? How we will call here, that is the main question. So we already, the main function what we have, this one that we are checking, that we have started 0, but we have not called here the helper, right? So what we have to do, we will take what we can do, I can take helper outside of the class here, right? And then I will start from here. We will make the first base case of this problem, right? This is we can say base case if this is null, right? But this base case is for the root only, right? Similarly we'll do for the root case. You only have to copy this one here to here, paste here, only make root. We are passing here what, root. So we'll do for the root, right? And then we have not passed 0. We will pass what, 0. We will pass 0. We will return 0. Here we will return what, null, right? We are returning what, null, okay? Or better run null, we will do return. We are not returning anything, right? Because this is void, we will not return anything. Now here what we are returning, 0, because the return type is what, integer. That's why returning 0. So this is done. Now we have to take result. We have to update result equal to what? By default we have 0, right? By default we have 0 value, but we will initialize, and then we will take helper, and helper function we will call root, right? Root, comma, root dot val, right? And root dot val, max and mean, right? Max and mean, current max, current mean. And then we will return what? Then we should return what? Oh, sorry. And then we should return what? Result. Correct? I think this should be a static method. This should be static method. It will work. It will work, I think. Yeah. Let's try abs int where math dot abs int minus. We should do here minus. We don't have method, we have to do minus. Yeah, now it should work, but we are getting the wrong answer, right? Output is 6, it should be 7. Let me find it. We have started with what? 0. Let me go down. I'll check what we have. We will checking root equal to null, right? We will return what? We will return here 0, correct? Base case. Now we has base case return equal to what? 0. Then we'll call root val max will return result. This function is fine. Now we will come to here, we'll check the node is null, then we will return here only, will not go. And if that is not the case, we will increase and we will update possible result. Possible result will come math.max, math.abs current max minus node value here, node.val. This is the error. Then we will call current max, current mean dot node value, right? Then we'll call can mean minus node value. Okay, yeah, it's fine. I think it should work now. Yeah, so let's, very good. So this code is working fine. So we can see another approach now. What we have to do, this was the recursive approach, right? We'll do start and we'll make here star. Okay, and in this case what will happen, if there is n nodes, right? So total time complexity will be what? I can write here time complexity will be, if we have n node, right? If we have n nodes, right, then what will happen? Time complexity O of n. Okay, because since we have to visit all nodes, right? We have to visit all node once. And space complexity what? Space complexity is what? Because we have on, right? And we'll move to, in the worst case will be on, right? And the best case will be what? O log n, right? So we have to take worst case, that will be O of n, correct? And if this is the best case, then O log n we will have, right? Now we'll see another approach that is called this is called approach 2, and we'll take maximum minus what? Minimum. Approach 2. This is approach 2, and we'll figure out. Okay, so what we have in this, so given any two nodes on the same route, right? Same route to leaf path, any given path, right? Either left, right, whatever, they must have the required ancestor relationship, right? We will see it should be the ancestor. Therefore we just need to record maximum and minimum value of all route to leaf, right, path, and we will return the maximum difference. And to achieve this, what we have to do, we can record the maximum and minimum value during the recursion, and will return the difference when encountering leaves. So the first what we have to do, we will define the helper that we have defined like in the last program, and which takes 3 argument as input and return will do. Okay, the first is node, current node, then we will pass the current max and then current mean, and minimum value will when value along the route to the current node, we will do in the like we have done. And function helper return current max minus current mean, and when encountering we will leaves all, otherwise it calls helper on the left on right subtree and will return their maximum. So we have to run helper and on the root, right? So let's start that we have did already here. So these are the function we have already. I'll copy this whole code and we'll update it. Okay, so this is we have, right? So we'll start from here only. I'm not taking result now. Okay, we'll take if root equal to null, we'll do the same case, and then we'll call we should call here what the function helper. Okay, and helper will return the everything. Okay, that what you can difference, max difference. So in this we will pass root val. Okay, three things we will return. Now we will have the same function we have, right? We will have the same function now. If we root if the root we have now node equal to null, we will return what current max minus mean, right? So now this time we have to update current max minus current mean. We will do here if this is null, right? Then we will check, we will not calculate this one this time. We don't require result, but we will update current max and mean. So current max, what will have? Current max we have node value, current mean we have node value, correct? Now we'll take a very simple thing, that is left and right. Okay, so this is called left. You can take it as int left equal to this one, and we'll take int right. Actually we are calculating directly from here. Okay, from the left and right. Okay, I think no doubt. And the last in the finally what we have now, we have the current, we have max, we have everything we have, right? What we will do here, we'll do math dot max and we'll find into left and right from where you have got. So actually it calculating sub children's max, and whatever from where it get the max, right, it you will return, right? Let me come here, we can come here. So this, if you pass this node, right, if this we will pass this node, what we have to do, we will return from there to we will call internally to left, means this 3 all children 1 6 5 4 7, we will calculate all this and will return some value. Similarly another child 10 14 and 13, this will calculate its maximum difference and it will return. So finally we will have two value left and right in which we have to judge which is maximum, and in this case it should return a maximum value. Okay, so it is saying okay, we have to update this int value, right, because we are returning integer, correct? So now we have to submit this. The code is working fine now. So in this program, if you any doubt, please ping me in the comment box, and let's understand the complexity. What will the complexity will remain here? So I'm copying these things from here, so we don't need to write again. So complexity will remain same for time complexity, because we have to visit all nodes once, and space complexity will also remain same, because in the worst case we have to move on, but the best case will be O log n, correct? So this will remain same. So thank you guys. If you have any doubt in this program, please comment me in the comment box. I'll be help you there. Thank you so much.